Cool. So what I'm going to do is to kind of walk through an example use case. So this is a customer support chatbot for a company called Spotify, which is very different than Spotify. Basically, users can ask a question like, how do I cancel my subscription? This will go to a knowledge base. It will retrieve knowledge and basically call an LLM. This is like a standard RAG chatbot. I think most people here are familiar with it. And basically, this is how you typically get started. You have a system prompt, you're a helpful support assistant, and answer solely based on the following context. Like you basically go to a knowledge base, retrieve some relevant knowledge from your vector database, and you basically copy-paste it into the prompt. This is basically a RAG in a nutshell. And this can generate answers that are specific to your data and not like generic LLM answers. So we basically had this system prompt. We shipped this app to production. And we have the first user. And the first user, of course, asks, how can I cancel my plan? This is the way users are. And the LLM actually generates a good answer. By the way, this is based, like, I didn't write this. It's not fake. It's like based on GPT-4 with the real Spotify knowledge base. All the examples you're going to see in the next slides. So this answer is good. And then, users can be a little bit annoying sometimes. So they keep asking questions. And so, how can I cancel my plan? Blah, blah, blah. And if I bought it with an Amazon gift card and so on. And the LLM still responds in a good way. So that's good. And then the user becomes even more annoying and asks, how do I cancel my Amazon account, which is kind of not really related. And this is real part of the real answer. The LLM actually hallucinates UI elements inside Amazon.com. Okay, so there is no button in the Amazon website of Spotify subscription. This is an hallucination. So what does typically happen here? Basically, the developer goes back to the system prompt and adds a guideline. You cannot assist with any service that's not Spotify. But then comes another user. And the user says, I downloaded some music from the Pirate Bay. The Pirate Bay is this illegal torrent website. Now I want to upload it to the music player. How can I do it? And again, this is a real answer. The LLM just describes how you can upload illegal music to the music player. So super, super silly stuff that can easily happen. I'm sure all of you have encountered it. So the developer goes back to the system prompt and adds another guideline, right? And this is basically infinite. Like, you keep adding more and more and more guidelines to the prompt. You keep adding, do not mention competitors, do not talk about torrents, do not give financial advice, and so on and so forth. And the problem is that, while prompt engineering is really important, basically, as you add more and more guidelines to the prompt, the accuracy of the model degrades, right? So this is actually, this was proven in multiple papers, but I really like this one, Lost in the Middle. Basically, it proves that as the answer to the question is in the middle of a prompt, for prompt sizes that are getting longer, basically the accuracy degrades. Make sense? So I think the main question is how you can actually transform these guidelines, all of these kind of instructions, to something that's much more tangible, something that's much more real, much more enforcing, and less kind of a suggestion to the LLM. And I think in terms of the set of problems that people typically encounter when they deploy LLM apps to production, there are many different types of problems. I like to classify them into two categories, which is basically type 1 security and type 2 reliability. So security talks more about, when I deploy a customer-facing application, what are the different security implications that can, happen while users are kind of trying to attack the chatbot, right? So an example could be prompt injection attacks. Well, basically, the user just overrides the system prompt, overrides the task by saying something like, ignore everything you just heard and do this instead. right? So this is a classic prompt injection attack. Different type of attack is prompt leakage, where basically users can leak your system prompt and the different function calls and so on. Sensitive data leakage, this is really important for some applications. You really want to make sure that you're not sending email addresses, phone numbers, credit cards, social security numbers to to OpenAI. And then I think, from this list, and this is, just the very basic things, this one is the most risky. So, generating code with LLMs is really, really, really useful. For example, you can use LLMs to generate SQL code and then use that to query databases. So kind of like a data analyst, as a chatbot. And also, people use code generation to generate charts and all sorts of different things. So the question is, what happens when this code actually has vulnerabilities? Or not even vulnerabilities, what happens if the LLM just hallucinates a while true and basically, this makes the app stuck or something like that. So that's security. And then the second part is reliability. This is more about the quality, the product quality. So how can you make sure that you have no hallucinations? How can you make sure that the LLM doesn't, say anything harmful or sexual or violent or all of these things? So these are two different categories that I like to kind of split the different problems. And essentially, the question is how you can actually transform these guidelines, that you saw before, to actual guardrails. Now, there are all sorts of different methods how to do this. And I'm sure, if you build an LLM app, if you are thinking of that, you are checking, how to build these kind of safety measures. I think one approach that works kind of well is basically, if you are familiar with the OpenAI moderation API, this blocks basic things like, sexual content, violent content, and things like that. This is one thing that could be useful. And typically, what we do see is people start using LLMs in order to kind of evaluate the prompt and the response, right? So basically use more LLMs on top of the existing LLM to basically check, hey, does this contain financial advice? Does this contain a prompt injection attack, and so on? So this is the method that works the best right now for guardrails. So basically, our product is called Aporia Guardrails, and it's being used by, I guess, two types of companies. The first type of company is more, large enterprises that are not like, doesn't have this startup vibe like OpenAI that can just release a buggy product. Basically, they really want to make sure that their agents are highly, highly reliable. And the other is different tech startups. So basically, our product sits between the application, the RAG chatbot or the AI agent, and the model. So it doesn't matter if that's ChatGPT or any other. And it's basically acting like a firewall. So it's observing every prompt that goes to the LLM and every response that comes out of the LLM. And the special thing about what we've built is that a couple of things. So first of all, it has really, really, really low latency. So if you're thinking about real-time applications, real-time chatbots, you really don't want to basically add a lot of latency just for guardrails, just for making sure that you don't have any financial advice and things like that. So we have actually fine-tuned small language models that are highly specialized just for guardrails. So these also have really low cost. You can see the benchmark right there compared to GPT-4. And then not only that the latency is really small, but the accuracy is also really high. So it's higher than GPT-4, for example, for these guardrails models. One thing that's particularly important, and I've seen this a lot, especially in voice applications. So if you're building a voice agent, streaming, really important. Like you want to make sure that the response is, you don't need to wait until the LLM call finishes to actually show it to the user. So one thing that Aporia can do is actually fact-check the response, fact-check the tokens as they're streaming to the user. Okay, so it's kind of working as the response is streaming. And then while basically GPT and the other LLMs have some built-in guardrails. These are mostly generic guardrails, like don't talk about suicide, don't talk about sexual content and things like that. But then, when you're DoorDash and you're building an application for Dashers or things like that, you have really specific guardrails that you want to add, right? So guardrails that are specific to your use case. So that's something that you can do very easily. So once someone adds a policy, we'll basically fine-tune an SLM. That's really good at detecting this. And this is something that we typically see more on enterprises. Basically, instead of calling OpenAI directly, instead of calling the LLM directly, they typically deploy a layer that's called an AI gateway. So an AI gateway, you can think of it like a proxy between the user and the LLM. And it basically helps you avoid vendor lock. It helps you avoid rate limits and things like that, just by kind of switching LLMs and having basic control and observability, more from a technical perspective. So if you do have an AI gateway, you can basically plug and play guardrails so that every single new project that someone starts a new LLM-based project will get guardrails out of the box. And then I think a really cool part, and this is a YouTube video that I really want you to watch later on, but this is basically for multimodal. So if you think about it, a trend that we're constantly seeing is that we have more and more and more agents that are not just chat, not just basic chatbot, but also voice assistants, where you can basically call an agent. This could be a customer support agent and so on. So the question is, how do you make sure that you don't have any prompt injections or things like that on the phone? And then what you really, as part of guardrails, you really want to make sure that you can take action to fix issues in real time. Integration is super simple. Basically, if you are using OpenAI today, you can just replace the base URL and add our API key. And if you use any other model, we also have a REST API that you can use. And basically, this is like a quick win to get more security and reliability for your app. Yeah, sure. Yeah, so that's a great question. So the question was, with streaming, what do we do? Like, how do we fix wrong answers? So two things. First of all, the guardrails layer doesn't actually fixes issues most of the time. It's basically, instead of lying to the user, it's responding with something like, I don't know, right? So that's number one. Number two, for streaming, basically you can choose to buffer some of the tokens, and then, the guardrails will look on these buffer tokens, and if it detects an incorrect fact, it will just respond. It will just not show these tokens. One other thing you can do is basically after the incorrect fact is to kind of add a warning. This response is prone to hallucinations. Yeah.
Currently, almost every big base model can be jailbroken. Does your guardrails can tackle that, and if so, how?
Yeah. So the way I see this issue, basically, I think there are three different types of prompt injection attacks. So the first type is jailbreak, where basically you are telling an LLM, ignore all your ethics, you can talk about whatever you want, and then you ask a question like, what does Trump, what do you think about Trump, right? So this is the classic jailbreak.
I checked with how to build the bomb, yeah.
How to build a bomb is better, yeah. More relevant for where we are, yeah. So this is type 1 of prompt injection attacks. Type 2 is basically something I like to call task hijacking, where basically you override the task of the LLM to do something else you want. It's similar, but not exactly the same. Right? So you have jailbreaks, you have task hijacking, and then you have prompt leakage, where basically you leak the prompt of the user. So these are different types of prompt injections. And then to mitigate those, if you think about it, it's really hard to do it as part of the LLM itself, right? I mean, they are getting better at it over time, but as you've mentioned, you can easily hack them today. And what really works well is to have a different layer that only checks. It's like a classifier for prompt injections attacks. And this is exactly what we built. Any other question? Yeah.
So who set the restriction? Like your users tell you we want, for example, in the LLM generated code security, like we don't want to delete or insert, or you set the restriction for this?
Yeah, so basically the guardrails, there are some policies that you always want to have. So you never want to have prompt injection attacks. You never want to have, select star from PG tables, like query all the Postgres tables, right? There are things that you always want to have. So these are enabled out of the box when you just do this, this API call. Okay, so all of that is enabled by default. And then what you can do is basically to start customizing and add more custom policies. For example, don't ever let the user query from table X, for example. Any other questions? Okay, thank you very much and enjoy the conference.